I know we worked with proving congruency last time.
Yeah.
I actually have two different things that we could do today if you don't have anything. And that are, I know we did one of them, but I can't remember which one we did.
Okay.
Which one of these did we do yesterday?
I thought it was the number 2.
Every statement has a reason?
Yeah.
Okay. Well, we have 3 more problems, and we didn't do any of these 3 over here?
No.
Okay. Well, if we need something to do, that's 3 more problems involving proving congruency.
Okay.
But I don't know what you did in class today. Maybe you did something new and you want to cover that.
No, we just took a quiz, so not really anything new. But...
Okay. Well, let's do this then. Do you think you did okay on the quiz?
Yeah, it was all material that I pretty much knew how to do, so.
Okay, cool. Pretty sure this is the last time in geometry you're going to have to do 2-column proof. And that's with congruent triangles. Everything after that, I'd be surprised if you ever present me with a proof problem again. But these aren't too terribly difficult to do. What's statement 1?
The given.
And we're trying to prove 2 triangles are congruent. And you see which 2 triangles. There's actually only 2 triangles in this picture.
Yeah.
There's this one and there's this one. Okay. And their statement says that that little section is equal to that little section. And it also says that that big line is equal to that big line.
Yeah.
So, how many pieces of information of the 3 do we have? In other words,
we have 2.
So we have SS. What's the third thing going to be? An A or an S?
Probably an A. Or maybe an S.
Well, it could be an S, but they've told us this and this, but they haven't given us anything about BN and LG. And notice they would not have to be the same lengths. If I move BN up just a notch to there, it's not going to be the same length as GL. But then NI would change, so you can't do that. But which angle are we going to find is equal in both triangles?
Angle I.
Angle I, which looks a lot like LI, but is equal or congruent rather to itself. What's the reason?
Reflexive.
And now we have 2 sides and an angle. So we can say LIG is congruent to triangle NIB based on what?
Would that be the CTCP?
Not yet, no. In other words, this problem we're merely trying to prove congruency. So it's either side, side, side. It's the 3 letters.
So that'd be side-side angle, right?
Let's go over that. Here's the way to do this. Pick one of the triangles. Okay, I'm going to draw a picture of it because a lot of people make this mistake. I'm going to pick the triangle on the left. We know that side is congruent. We know that side is congruent. And we know that angle is congruent. So state those in the order that they appear, and it doesn't matter if you go left to right or right to left. What do you see?
Left to right.
So you have side, angle, side.
Okay.
And just for further clarification, that does not prove congruency. Side-side angle does not prove it. So whenever you're doing one of these problems and you know you end up with two sides and an angle, you know it has to be side, angle, side. That's the only one that does it. That's the only combination of two S's and an A that proves congruency. But this is the way to look at it, is to look at one triangle only, figure out which three pieces of information you know, and then you could either, in other words, that's either side, angle, side, or if I started from the right and went left, it would still be side, angle, side. But the only way you could come up with side, side, angle is if you reversed directions. Notice that to get side, skipping the angle, and then crossing to the other side, and then going back to the left to pick up the angle, you never want to do that. You never want to go the opposite direction. Pick one of your end pieces of information and just go in the order that you see. And that's all there is to that problem. They didn't say prove BN is equal to GL, but we could, at this point, we now know that line segment BN is congruent to line segment GL, and this would be the corresponding parts of congruent triangles are congruent.
Okay.
So they just didn't have us do that extra step on 24. They just wanted us to prove congruency.
Okay.
Again, here they're just trying to prove this triangle is congruent to that triangle. And the given is two sides are equal.
Yeah.
Or congruent, excuse me. So either we have a third side or we have an angle. That's what we're looking for.
Okay.
The two sides that are equal are HW and MW, and then this one and this one.
Wouldn't WA and AW be reflexive and congruent?
Yeah, and you don't even need to switch the letters. You can just call it WA and WA.
Okay.
Again, the reflexive property, which these exercises seem to love. And now that proves congruency. Based on what reason?
Side, side, side.
Huh? And again, if they wanted to get a little more complicated and they wanted to say prove angle H is equal to angle M, or congruent, the angle M, that would be CPCTC.
Okay.
Make just a little bit more room. Oops, hold on, I didn't want to do that. This is a little more difficult than what we've been looking at. The given is LM bisects angle BLA, and line segment BA is perpendicular to line segment LM.
Okay.
And again, they want us to prove this triangle is congruent to that triangle. And we should immediately see a red flag. We've got a line that is common to both. Okay? So at some point in here, we're going to use the word reflexive again, and we're going to say LM is equal to LM. But before we get to that, let's go more in order of logic. In other words, let's take their givens and figure out what that means. If LM bisects BLA, then what is true?
That BM and MA are equal or congruent.
Hold on. It didn't say that LM bisects this line. It said that LM bisects this angle.
Okay, so it's that those two lines are equal?
Not lines, angles. In other words, you can either bisect a line, which splits it into two equal parts, or you can bisect an angle, which splits it into two equal angles.
Okay.
So which angles are equal?
BLM and MLA.
They're congruent. And the reason is definition of bisects. In other words, bisects means split into two equal parts. And it doesn't matter if you're bisecting a line or you're bisecting an angle. You're going to split it. You're going to split it into two equal parts. I think that's the answer. I don't believe there's a theorem involved. It's definition of what bisect means.
Okay.
Okay, and now we've got the second given, which we haven't dealt with yet, is BA is perpendicular to LM. What does that mean?
BA is perpendicular to LM.
Uh-huh.
It means that they meet and make a T.
They make two right angles.
Yeah.
So I can say that angle what?
That LMA is a right angle.
Okay, how about we'll start on the left. BML is equal to 90 degrees and angle LMA is equal to 90 degrees. And based on what? There's actually
the definition of right angles.
Well, no, not really. There's a right angle theorem that says when two lines intersect at a right angle, you make four 90-degree angles.
Okay.
In other words, whenever you have two angles, two lines making a right angle, that's the perpendicular part, well, you actually make four right angles. So now I don't know that we necessarily need another statement. It's possible that somebody that was really, really picky would say this is a right angle and this is a right angle based on the right angle theorem. And then you would put another statement saying one is equal to 90 degrees, definition of right angle. The other is equal to 90 degrees, definition of right angle. You know what I'm saying?
Yeah.
Might be that you would want that statement. But now we have this angle is equal to this angle, and we have that angle is equal to that angle. So we have two angles. So what must the third letter be?
Two angles.
Has to be an S. Because angle, angle, angle does not prove congruency. So you know it's not going to be a third angle. In other words, we're not going to be able to prove that B is equal to A, and that would not prove congruency, even if we could. So we need a side. Which side is in here?
LM.
And that's based on reflexive again. Reflexive property. And finally, that's enough to say LBM is congruent to LMA based on what?
Angle, angle, side.
No. Here's the way I want you to do these. This is tough. Most people have trouble with this. Eliminate one of the triangles.
Okay.
Which sides do we know?
The right side.
We know that one. Which other side?
LB.
No, we don't know LB. We only know one side, but we do know this angle, and we know this angle.
Okay.
Okay? By eliminating the other triangle, I think it clarifies the situation. If you're looking at that and you know it's congruent, what is it? Just go in order.
Angle, side, angle.
Yeah. And it doesn't matter which order. I can start from the bottom and go up, or I can start from the top and go down. But it's not angle, angle, side, which is a different theorem altogether. Okay? I realized yesterday when I did 5 sessions on this same page over and over and over, I couldn't figure out a good way to explain how do you come up with the order of the letters. I kept referring to it as going clockwise or going counterclockwise. And finally, I realized that if you eliminate one of the triangles, then your brain is not trying to match up which angle that is congruent with. You don't need to know. Okay? You don't need to know how the other triangle is positioned. It could be positioned like this. And I wouldn't care which angle was congruent. Not yet, at least. Okay? The key as to the order of the 3 letters is merely drawing one of the triangles and labeling everything you know. And what we know is that angle, that side, and that angle. And then just go in order. We've got a few minutes here. Let me explain briefly why side-side angle doesn't prove congruency. Or did I do this already yesterday?
I think we did.
Yeah, in other words, you can have a triangle that has those Notice side, side, angle. And certainly I can draw a congruent triangle that's the same thing. 40, 10, and 8, those are congruent. But I can also draw a non-congruent angle. In other words, that's still 40, that's still 10, that's still 8. So just knowing side-side angle does not prove congruency. Sometimes it does. If this angle is 90 degrees or more, then it does. And in fact, let's talk about that. They didn't give you any problems that highlighted that. But let's talk about right angles, because there's one last proof for congruency, and that's HL.
Okay.
HL means the hypotenuses are the same and one side is the same. Doesn't matter which side, just one side is the same. Now, this is a special case of side-side angle. So in a sense, this is side-side angle. And side-side angle does prove congruency as long as the angle is 90 degrees or greater. In other words, if I gave you this problem, I made it an obtuse angle, not even a right angle, and I said, they don't actually have a theorem on this, but it's true, and that is that if I knew that side was equal to that side, and I knew that that side was equal to that side, and I knew that that angle was equal, well, notice we have side-side angle, and it wouldn't normally prove congruency, but as long as this angle is 90 degrees or more, it does. There are now not two ways you can draw that thing. There's only one way. So when you're presented with geometry problems that have an obtuse angle, and the best you can come up with is side-side angle, it works. And for the same reason that HL works. HL is, notice HL only works for right angles, so what it really is HLA, right? In other words, you still need three pieces of information. You need the right angle is equal to itself, and you need two sides. It's just that with this special situation, it's always side-side angle. In other words, if I didn't know that side there, as long as you know the hypotenuse, well, actually, if you know both sides, then you have side angle side, so that works. But even if you know the hypotenuse and the other side, that is still, no matter which order you go, you see why we can't go this way, clockwise, and start here? We'd be starting in the middle. In other words, this would not be side, angle, side. We've skipped that angle. You can't skip anything. When you put your three letters together, everything has to be next to one another. If I'm going to start at an extreme, that's where I'm going to start. Since I only have two sides and an angle, this would have to be side-side angle.
Okay.
Yeah, that's actually not a good explanation for why you can't do that. I just realized. But I think you're getting it, and this is just a special case that applies only to right triangles. All right, I guess we can. I can let you go a little early, and hopefully, let's see. This is Tuesday, isn't it? So we're not due to meet again until Thursday. You'll have new stuff by Thursday.
Yeah.
Sounds good. Mark, I will talk to you on Thursday.
All right. Thank you, David.
Bye-bye.